Welcome to App School. We are going to learn how to actually build tools that are more complicated than generators on Urbit. And to do that, we're going to have to delve moderately deep into some ideas like what exactly is a program? What does it mean for it to run or maintain a state on Urbit? And just get a little bit deeper into what the system looks like and some of the things that Urbit as an operating system can do for you. Now, the neat thing about this is that it gives you a pretty good insight into why Urbit is built the way that it is. And you'll also get familiar with the parts of Urbit that are fairly polished and close to complete, and the parts of Urbit that need some ongoing user space development. And with any luck, you'll be able to contribute to that latter by the time you come out of App School here. Now, Jack, you're here now, aren't you?
Hello.
Jack is going to be TAing App School. Most of you probably know him already. One request I have for you, Jack, it will not let me turn off the waiting room. So if you could keep an eye on participants and let people in if they come in while I'm talking, I would appreciate that.
I don't know how to see the waiting room.
Oh, I think it's doing the thing where it's not letting me co-host either. So, oh well, I guess we'll just live with me having to camp on that. All right. Let's go ahead and share. Let me see. Okay, so in the past I've worked in typically in just the command line, but I'd actually like to experiment with doing everything in in VS Code this time. VS Code has some highlighting and stuff that the command line doesn't give me. Now, the downside, I believe, is that we lose part of the screen because of the way that Zoom on Linux renders things. And so I need to be careful with my screen real estate here.
Yes.
So I'm going to try and jam everything all the way over here on the right and not use that space while I'm working with you. All right. Can you see the left-hand side of the screen right now? Or is it doing the black?
No, we can't see it.
Black.
Zoom. Okay. Let's see. We'll do it. Let's see. Oh, I'm going to have to actually, what I should probably do then is just actually
If there's any way you can move
that
over to a separate. Oh, that helps.
Will this work for you? Yeah. I'm frantically rearranging things here, and Zoom keeps mousing over where I'm trying, windowing over what I'm trying to look at. Okay. Every time I use a new tool chain, I run into new interesting problems. So, all right. So the advantage of this, though, is that I can show you text with highlighting. So if I write Hoon here, then it should remain visible to you. All right. I think we're in good shape then. Okay. Administrative stuff. We're going to have 8 lessons. We would like you to complete 7 of the 8 homeworks to be considered a finisher for App School. And they should be manageable in size. Jack has reworked the Hoon School lessons pretty substantially, and I think you should probably expect a similar amount of work with App School at this point as we move forward here. Now, I am working in a directory that has a new fake ship, Azad, directly inside of it. Let me close it in the other window, and then we can just see it here. Okay. So if I want to run my Zod, I can do /Zod/.run. This is not the only way to do it. You can also do Urbit Zod and run it that way, and that'll run it on whatever Zod you have installed over your entire system, and it'll pull everything up and then just run a regular fake Zod for me here. Okay, so something of a philosophical question to start off with here. Some of you who have programming experience with other languages will have a model for what this answer looks like already, but take it and sit with the question for a little bit. What exactly is a computer program is the first question. And the follow-on question is, how does an operating system know how to load and execute a program? Okay. So what do we mean when we say that something is a computer program? What is that? What does that describe?
Some kind of executable.
Set of instructions.
Okay. And then Nod-Palmux has in the chat a set of instructions for computing a task. All right. So what we have is some sort of sequence of kinds of things that we'd like to be done, right? Yeah, Andre says a sequence of instructions, right? Like there's some sort of definite order that comes through trying to put everything through. And so it gives the computer a way to think about calculating each part of this forward as it works. Now, when we run a program on a particular operating system, the operating system needs to know how to access and run that program. And so if you're running Mac OS and you attempt to double click on a .exe, you're going to get some kind of error that it doesn't recognize the binary format of this application or this file or whatever it is. I don't know if they even feign to know what an exe is. And you're gonna have the various problems. Any other configuration, Windows trying to open a Linux file and so forth. So every platform defines not only a way to think about like what a program is, like how do you run things in sequence, but where to actually start a program. Like what does it look like to actually load a program? Now, one analogy that I like for this is that of a train car, right? So when you think of a train, you're thinking of something like a locomotive when I say a phrase like that. But there are other kinds of things that can operate on a train track, right? There are hand cars, there are high rail trucks, anything that sort of speaks the API, the application programming interface of the train is capable of running on those rails there. Urbit has an operating system inside of it. In some sense, it's kind of, the behavior is defined by the operating system. It's called Arvo. All right. And Arvo as Urbit OS is essentially an event handler and a dispatcher. It's a way of, it receives an event, whatever we mean by event. We'll get more definite about that next time in particular. And it turns it into, like whatever the next event is, whatever the next result is. If you've worked with something like the Java virtual machine before, if you've programmed on a system like Ethereum, if you've done Windows programming, you've done Mac programming, whatever, they all have their own way of sort of conceptualizing the main loop, right? Like, do you check and see what the next thing is, you handle this thing, you produce a result, maybe you send it to someone else, and then you check for the next instruction, the next event, the next move, whatever the next thing is in your system. Arvo provides what we're going to call a user space app framework. Urbit uses the terminology kernel space and user space very frequently, more so than you would run into in a lot of other spaces. You do see this terminology in use in systems like Linux, but for instance, if you're working on Windows or Mac, you're probably never working in kernel space unless you actually work at Microsoft or Apple, right? Like, it's extremely uncommon for an outside developer to work in kernel space, to work on like what actually makes the system the system. So everything you do on those systems as a third-party developer takes place in user space, and so you sort of don't really need this distinction. On a system like a Linux or a Unix, where you can actually work directly on the kernel, the part of the system that handles the interface with your hardware, the behavior of the languages and so forth, it does make sense to talk about kernel space. And so Urbit is going to have kernel space, which is essentially the domain of the core developers. And it's going to have user space, which is I'm going to say regular developers, but developers that are building apps, that are building agents. I'm going to use the word app and agent interchangeably here. There are some subtle differences. An app is probably the entire thing you're installing. If you go install groups or Talk, they come with a standard Urbit installation. If you go install Trill or Portal or one of these other tools that's out there, you're installing an app, and this app may have multiple agents that are working as part of it. Now, at this point, you have worked with Hoon for a little while, and so there should be some claims about Urbit that should start to feel more familiar to you. So if I tell you that every agent is a core, then you should be able to tell me what a core is. All right, so in Urbit, what is a core? Here's the test. You can unmute if you like, or you can just type. But like, what is a core? What does a core do for you?
It's a piece of code waiting for an input to give you a new output.
Okay, so we have a couple ways of thinking about it. Okay, so there's a code from input to output. And this will take place via expressions and arms. And then we also have a description in the chat of battery as a cell of battery payload. And so both of those give you a picture of what's happening with a core. The battery payload model is the battery is the executable code, the expression. And so that's essentially this part, right? That we have these statements that are mapping things one to another. And then the payload is the what I'll call here the input data, the context and the sample, right? And so yeah, someone says that code is data, data is data, right? So these things all get stored in there together. Now, what we're going to work with, we're going to jump right into now what a Gall agent looks like. And so when I show you this code, we're going to talk about like what looks familiar and what doesn't look familiar from this. But this code is a certain kind of core. All right. So from lines 15 through 25 here, we have a particular kind of core. And then there's probably some unfamiliar conventions here, but this is basically the simplest possible Gall agent. That might make, yeah, what would actually work better for highlighting is if I just put it in a, yeah, if I just put it in a standalone Hoon file, it'll give it to us here. Okay, so when you look at this, what elements of this do you recognize from what you saw in Hoon School? And what parts do you not recognize? So we'll start with like, what do you recognize? What looks familiar here? And let me just open a new window here so I can type here. All right, so familiar arms. Okay, so we have the little less labels here. All right, we have some gates. Yep, go ahead.
It's a door.
Okay, so it is a door. All right, what runes are being used here besides? So we have a bar cab. Actually, I really like to label these too, so you get used to the names if you're not already used to the names. Are there any other runes you see here?
Yeah, Zap. I think there's a lot of crashes going on.
All right, so we've got crash, zap. All right, so we have this Zapgar. Have you seen Zapgar before? I think you've probably not.
In
I
tests.
think it was in the type sphere.
Okay. So we
Yeah,
have
it's
this one.
output.
Yeah. All right. So now let's look the other way. What is unfamiliar?
The input is Gal, and we haven't learned about Gal yet.
Okay, so this is our sample to our door. All right, what else looks odd here? Do we know what a vase is?
We should. Yes, we do.
I mean,
So the vase is a pair where you have the type and the value inside a pair. Yep.
and so this is, yeah, it's a way in Hoon, because in Hoon, all code is data. We don't transmit. There's a sense in which we don't transmit code from one place to another. We transmit data. And then when we transmit it as a vase, we can use the type that's the head of the vase to then turn the data, that's the second part, back into code or data or whatever we need it to be. So it's a processing convention that we use very frequently. And the deeper you get into the system, the more you use it. But here basically we're saying, I can hand, well, we'll use this in a minute, but I can hand you a value. Let's see. So if I do this on, what's the value, 6, then you can see I get a cell where the head is Pat UD and the tail is the value 6. And so I can use that to reconstruct this information. So if I have something else like a message, then my chord in this case, my Pat T, gets turned into the raw numeric value, and then a type gets transmitted with it. So I can reconstruct that on the other end of whatever data transmission or data passing that I need to do. All right, there's a cage. This is a pair. Let me do it in the same language here, of mark and vase. All right, so think back to Hoon School. What's a mark? What does a mark do for you? Where did we see marks?
It defines a type.
Okay.
Yeah. File.
Okay. Yeah, so there's a few ways, right? So I'm gonna indent this because we actually have seen it. All right, so there's a sense in which it's a type definition. There's a sense in which it's a data type of a file, right? The way that I think of a mark is that it is a set of transformation or representation rules. So a mark like text or Hoon or PDF or whatever you might write is basically a rule saying this is how I can present it as the thing that you want if I can find a transformation rule from noun to wave or text to PNG or text to JSON or HTML to XML or whatever kind of transformation path I can have. They're actually used more broadly than just for files. Files are the place that you encounter them first, but we're also going to use it when we pass data from one point to another. We're going to use it as a way of validating our data. So we can also think of it as kind of a data validator. It partakes of all of these kinds of things.
This sounds a lot like type signature. Would that be a good way to describe it?
there are elements of that, but I think it also includes the way that you can get from one thing to another. So it's not just validating it against a type signature, it's giving you a rule to get from one place to another too.
Yeah, it's a bit like a MIME type if they were implemented
Yes.
correctly in web parlance.
That's a good way of putting it. Yeah, as a mark like this blob can be interpreted as an image, or here's how to interpret this blob as an image. Both in a sense, right? So the first part is saying it's more, well, I guess in the sense that you're asking here, it's more the rules themselves. The mark is the rules themselves. And if you can access, so in Urbit, ultimately everything is a noun. Okay. Everything is a noun. And a mark is basically saying, do you have a path to get from a noun to the type that I need this to be? Right. So if I have an arbitrary noun, I have a binary tree of data, maybe this has a structural mapping to text, and maybe it doesn't, right? The same way that if I'm on the command line and if I try to open an MP3 file with a text editor, things are going to break because there is no mapping between those values there. Okay. We will work with them more. And I believe starting this lesson, if not this lesson, then it'll be in 2 lessons when we get back around to Gaul. But for right now, sit on a mark, and a cage matters because a cage is a pair of a mark and a face. So ultimately, for some of these things, when we pass in data, we're passing in a mark, a type, and a value all together. So we have a data validator, and then we have the data itself, including the type of the data with it. Okay. A path. All right, so a path is a list of PAT-TA or knots. Okay, and so this is the way that we identify conceptually, hierarchically, where something is located. And this could be on a file system. This could be a web URL. We use paths in both cases, or we could be using a path to describe some other kind of way of getting from data, identifying a unique data location. We are actually going to use it for subscriptions. We're going to be able to define a path to subscribe to, and this is how we're going to access and look at data from one agent to another. That's where we're headed with that. Let's see, there's also a wire. This is a unique ID for a request. So every time we make a data request, we're going to use a wire to keep track of which data request it is. So if I ask you for data twice, I have a little label on there so I can tell them apart when I get the data back. This is what a wire is going to do for us. In some regards, this terminology is satisfactory. In other regards, it's Urbit, 4-letter words. We'll get around to it. What about this one? Tick ... on init. Has anyone looked at cores closely enough to dissect what's going on here? So first off, what is this tick doing at the front for us?
It prepends a null.
Okay, prepends a null.
Huh.
This is a unit. So units are the way with maps, for instance, that we distinguish between an answer that is 0 and an answer that doesn't exist. So a unit would be of a particular type. I can type here. And so this lets us distinguish even between null, getting a null back, and getting, the answer that there's nothing there. There's nothing at that particular value. But we use tick generally to do this. Tick is structurally prepending the sig, prepending the null. I actually don't prefer this terminology, but you will see it frequently, so it's worth pointing out to you here. I prefer to be explicit and just write the SIG prepended. Let's see. There's a term which is an alias of pat TAS. There's a sign and a sign arvo. These are going to be incoming events when we request things. Okay. Oh, one more thing. What does ... on init refer to? So what does a dot by itself do?
Yourself.
Okay. Well, okay. So yes, you are correct. I was actually thinking of the other dot, but you're right. It is yourself. What does the other dot do? So the first dot is self or subject. Second dot is resolves against, right? Right, like we would have used this when we were writing expressions that needed to be nested inside of each other. And so what ... on init is, this is a shorthand for what is the context of the on init arm, which is the current core. So this is a way of referring to the current core. So on init is just returning a copy of the current core to you. Essentially is what this is saying. All right, so we're going to do more subject-oriented programming as we work through this. Term and tank. Some of these other things are in there, but they're pretty minor, and we will not worry about them substantially right now. But let's go ahead and actually implement this. You know, this is the I was talking to Jack about this. The problem is that the problem with App School is that you start App School, and then the first thing you have to look at is this 10-armed agent here, right? Like you open this up and the decapod is looking at you right from the beginning, and you have to get used to like, okay, what exactly is this saying? But we have a core that has 10 arms. So this is what defines an agent in Gall, in user space. So anytime we talk about an Urbit program, here we are defining the interface that it must adhere to. Anything that has these 10 arms is a valid Gall agent. And then we are also providing it with some information and some state. Okay. And when we do that, we're going to be giving it the bool, which is the current, it's basically the current context. It's some information about the state of the current, you know, the agent, the ship that you're running on, the timestamp, and so forth. So you'll be able to use that information as well. Now, there's a question in the chat. Are we returning on init as a unit in order to signify a possible error? Not quite. We're not going to use it to signify an error, although that is the pattern match that's used elsewhere. And this is one reason I don't like this pattern match. And I would prefer to write sig like this, which would be structured the same thing. This first part is actually going to be a list. So we're going to be able to pass other information from it by doing this. So we will do that in a moment as we look at our second agent. What we need to do now is create a new desk, and we're going to add this agent to it. So this is going to be now essentially we're going to walk through what is our minimum viable agent, right? Like how do we build the smallest possible app on Urbit? So we need to create a new desk, and I'm going to call it alpha. Bar new desk alpha. And then I'm going to bar mount alpha. And while I'm at it, I'm going to bar mount the base desk in case I need any files from it as well. Now, every time we create an app, we are going to run it on a particular desk. A desk is like a Git branch, if you've looked at those before. If you've not worked with Git much previously, then you can think of it as essentially, it defines the universe of libraries and files and so forth that the program knows about. So it's only going to define that narrow set of things that are actually known about by my system. If there's a library that I need to include a copy of it on this desk, because the alpha desk in this case is going to be everything, the entire universe that it sees. It will be convenient to have two terminals open here, one running the fake ship and one of them outside in your own program, in your operating system. You can do this as well through whatever text editor that you're used to, the same way that you were working with gen files before. So we mounted it, we created it, we mounted it. Inside of Alpha right now, there's a sys.kelvin file, and there's a few marks that allow it to read a hoon or a noun or a text.hoon. But there's really nothing else inside of this at this point. What we need to do is we need to first thing we need to do is we need to create a desk.bil file. In Alpha. So this will be a list of the agents that will be run when this desk is installed. So we're registering that we are going to run this desk. And then the text that I had a moment ago, which I will share with you there. Okay, I just pasted it in the Zoom chat. The Zoom chat is a little bit of a pain to work with in that if you'll need to go, there's 3 dots when you mouse over, and you can go to copy, and that should copy it preserving spaces correctly. It tends to strip out the spaces if you just select and copy everything. So go ahead and copy that, just that text. And then I'm going to save it in, we're going to need a new folder called app. And we're going to save it as alpha.hoon. All right, so now we can see there's an app alpha.hoon. And then we're going to bar commit alpha. All right, and it may give us an error. And this is fine because, you're going to run into this the first time you create a new desk from scratch anyway. And right now it tells me that it has an error validating desk.bil because it doesn't have mark files for MIME or for bil. So the other thing we'll need to do is we will need to copy base mar bil.hoon base mar mime.hoon to alpha mar. So for me, that's what that statement looked like, because I'm currently in that directory. And now if I bar commit alpha, should load, yes. Everyone runs into this the first time they start up a desk. Once you have the appropriate mark files in there, then it should load everything. And Hoon, Urbit knows how to pull it in, knows how to actually resolve this. Now, we're going to test what we have. We're going to install our alpha. All right. Now, let's circle back around to a little bit of philosophy. What does it mean when we run a program? So some programs are what we could call batch programs. They're single instances. If I need to carry out a process, then there's a program that runs and checks that process, or it checks the status of something, and then it terminates. These are basically generators, right? A generator does a single calculation for you, then hands you back the result and ceases. It doesn't have any longer term sense of itself. An agent, a Gall agent, is more like many other pieces of software that you've run into, which are continuous. They're servers, and they will continue to evaluate for a long time, potentially forever, right? There's a sense in which to your operating system, from its own perspective, it runs forever because it only knows about the world while it's running. Your Urbit is designed to run indefinitely. The agents, the programs that you write like this, similarly will just run. So, Gall installing CentAlpha, Gall booted alpha. Alpha is running. So what that means is that Urbit maintains some notion of state. In this case, we actually gave it no state, but we will do that in our next stage. It will give it more state. We'll give it something to know about. And it maintains the core that is the basic interface to interact with it. So I can interact with this interface, but what does basically everything in this core do? It crashes. So if I do any interaction with it, I expect it to crash. So let's go ahead and poke it. The only way we know how, and just poke it with a little bit of a data there. All right, so that will be col alpha, Pam noun, and then anything, any data at all. All right, and it tells me that this thing has crashed my app poked fail. Now, on poke is a gate, and it receives a cage. And a cage is a pair of mark and vase. So the first thing that is passed in here is the name of a mark that Pam is telling Dojo that you're referring to a mark rather than something called noun. If I typed noun by itself, there's actually like some name in my system that's called noun, and it would go look that up instead of looking up the mark definition noun. So Pam is a label here that says look up the noun, actually interact with the noun. So mark this with a noun, and then give me a vase of null and whatever. If I zap gal null, what do I get? I get type null as a constant and 0. So it's a constant null. I could give it something else. It would give me the same crash because that's what it does. It receives the correct type, but then it crashes because that's literally the only option that this tiny agent has, is to go ahead and crash. All right, so there's not really much else for us to say here. Now, it does know about, let's go ahead and modify this. It does know about a bool. Okay, so I can write a program. This is essentially identical to what I had a moment ago, except now I've expanded it into tall form, and I added a sigpam, so it should output the bool. It will output the kinds of things it knows about the world before it crashes every time I poke it. So let me go back up and bar commit again. Tells me that it reloaded. It tells me that it bumped the version. And now if I poke it, it actually does spit out a block of information here. And this is the bool. These are the kinds of things it knows about. So it knows identity. It knows where the poke came from. It knows the agent that was poked. It maintains 3 lists. It maintains a list of outgoing subscriptions, agents that it is subscribed to on particular ships, incoming subscriptions, which are things that are subscribed to it, and then I forget what Sky is. Sky is a new thing they just added. That might be a remote scry thing. I actually need to go check that because it's not even in my notes because it was pretty recent that they added it. Then it also knows about entropy and version number and some other things that are going on here, timestamp and so forth. Okay. So, all right. So it has this information available to it. It just doesn't do anything with it right now. All right. So we have these 10 agent arms. Each one of them does something specific. So let's take a look at these real quick. So we have on, what do we have? On init. So on init is responsible for first time startup. Normally this means set up the state. So when you install something for the first time, maybe you need to register some API endpoints in, so that if you, so that it knows how to load something. If you install Trill, if you install Rumors, if you install Portal, one of the things that they're doing is they're registering the URLs that you will access them from. And then there's also internal state. We'll see what state looks like in a moment. There's an on save and an on load. On save, just I'm gonna use this. I'm gonna make up this word invases. It produces a vase of the current state, and then this unwraps the old vase and makes state changes if necessary. So if you make a change, if you add a new list or change the things that you're tracking, you need to register a new API endpoint because you expanded things. You need to unregister something because it's no longer relevant. On save and on load handle that pair. So every time I bar commit and it upgrades my agent, it will run on load. On poke means a single instance interaction. So I'm sending some data at it and expecting it to do something with it. On watch is a standing subscription. Urbit likes what I'll call a data flow model. It would like to just notify you that anytime you make a change that affects these particular data, please let me know so that I can continue to remain synchronized with what's going on. You subscribe to a particular group, and every time a message is submitted to that group, every subscriber receives a copy of that because that's what it means to subscribe for the data. Andre says, so on load runs upon the agent being upgraded, but I didn't get what on save runs. On save runs before then. So when you upgrade, on save will run first, and then on load will run. And if it needs to make changes, it will make the changes at that point. We will look at this more concretely shortly, but it'll run right before. On leave means quit a subscription. Sometimes there's special things you want to do with that. On peak means single time data request, like just let me know one thing about my system. On agent means receive data from another agent. On Arvo means receive data from the OS. Like I've requested a wake up timer, for instance, and it will let me know. So I've requested something through the network. Now it's come back to me. I have to decide what to do with it. And on fail is handle a crash. Okay. There's a lot of these. There's 10 arms. They're a little bit, it's a little bit clunky because you have to look at these in any particular agent, but you actually don't have to define most of them to make things run. I mean, most of these arms and what I have here just crash. They don't do anything special. But this is our basic vision of how a Gall agent does what it does. And from a long-term perspective of what does Urbit do well, what does Urbit look like in the long run, this is fairly complete. These are the kinds of things that you'd want an agent to do. And so we probably won't see major changes to this kind of interface in Gall. There's been some discussion about maybe having like an on breach arm or something that would handle if a peer breaches. But for right now, this handles the kinds of things you would like a standing service program to be able to do. Now, an agent, a Gall agent, is basically it's a state machine. It's going to be able to do certain operations. and make changes in response to those operations. So our second Gall agent will be Bravo. And Bravo, let me see if I can shrink this down enough. Rest of it's boilerplate. Okay. What you see with Bravo is that it has a lot more definitions at the top. Most of the things at the bottom. The ARM names look familiar, but instead of defining them the way that I did in Alpha, I've given them these default names, right? Like where did these come from? So we'll have to figure that out. From line 15 onwards is the Gall agent as we looked at it previously, which means the first 14 lines of this are doing something, some sort of context that's different from what we had before. Most Gall agents that you ever write will look about this complicated. So let's go through line by line and see what's actually going on when I run this. Part of this is here because because Hoon is a statically typed compiled language, and so we have to define things ahead of time so that the compiler knows that they exist and it knows how to work with them and interact with them. All right, at the beginning, we are importing two libraries, default agent and debug. Default agent we're going to use in a moment to define some standard arms like on save and on load. It just gives you nice handlers, so when you hit those arms, it gives you a little message that this arm is not implemented, but otherwise it basically crashes. It does the same thing that we saw before. And then debug is going to give us some tools to work with an agent to take a look at the state and so forth and see what's happening. All right, we're going to define a core at the top of this. This is not our agent core. This is a core that's going to define the state that is inside of this. Actually, I'm thinking about it. Let me give you a copy in the chat there so you can look at this. All right. When you looked at cores before, I believe Jack said you looked at lus arms, which are what you're used to, but you did not look at lusbuck arms. Lusbuck arms are very similar, but they are type definitions rather than like gate definitions. So functionally, what I'm doing here is I'm defining a new type that has a name, versioned state, and it is a union. Buck sen is a type union. So, you know, it's the same thing that we might write this way. Like that would be the same kind of thing. It's a type union. Right now it has one member, but if I were to add other states down the line, I would also have to let it know, okay, what are these other states? How do they interact with the system? To start off, we're just going to have a state 0. State 0 actually just consists of a named tuple. The head tag is 0, so I know which state I'm working with. I'm working with the 0 version state. I can tell this structurally because it has a 0 constant at the top. And it has a list of paths, which is named value. So that's going to be my state in my agent. Right now I haven't done anything with it, but this is what we have. And then I'm aliasing card agent Gall to just call it card because I never want to type card agent Gall again because it's a really long name and it's kind of a pain to work with. So this is resolving somewhere inside of Gall in the system. There's an agent that defines a card. A card is going to be our fundamental unit of communication from a Gall agent. We're going to define a card. We're going to send it to Argo. We're going to send it to another agent. It's the kind of thing that we receive in on agent or on Arvo. And this terminates our first core. So this is our state definition core. We're going to put this at the top of any non-trivial agent that we write. We have to let Hoon know and Gall know what's our state. What are the values that we're actually tracking? What do we care about? Then inside of this, first line here is we're applying some gate called agent that's inside of the debug library. Okay. I don't know exactly what that is so far. I haven't used it in context here yet, but it will let me ask certain things about this agent. This stuff is boilerplate. Most of the time, the only thing you'll change in any of the first 14 lines of this is what's actually inside of your state. You know, maybe you don't care about a list of values. You care about, you know, a name and an address or a list of addresses, these kinds of things. You'll change state. Most of the rest of this is boilerplate. It will always look the same. Bar tiz. Have you seen bar tiz before? Very possibly not.
But it's seen
tiz-
a lot
sorry,
of
tiz- tiz-
examples.
Tiz bar. Sorry, say that again.
It's seen a lot of examples in the
Yes.
documentation.
Basically, it lets you define something with the default value of that thing. So basically, I'm registering a name or a face, state 0. And rather than like sort of awkwardly like add everything in it like this, I just get that for free. It gives me an empty state. So it's useful when you actually have something complicated like this that you don't want to fill the whole thing out. Tizstar is registering an alias to it. So HEP refers to the last thing that was put in your subject, which was state 0. So it means that I will be able to talk about state anywhere inside of my agent, and it will always refer back to state 0. At this point, there's a lot going on here. We're going to spend app school dissecting this. I got to show it to you all at the front here, but we're going to spend the whole time working through the ramifications of this. So you're going to see this content a number of times before you're like accountable for it, right? Then I'm making sure that everything after this matches the type of a Gall agent, and then I'm defining my agent the rest of the way. Now, if I look at what's actually inside of my agent, my onInit is doing something a little bit more complicated than what it was doing before. Excuse me, my onInit. First off, it does return a tick this, and I'm going to call it this because I really think that's structurally better to just treat it that way. And so this is what it returns, and whatever it returns also seems to pattern match to this ket. So I'm not anti-tick in context. I think tick is excellent for units, but if what you have is not actually a unit, I don't think you should use it. That's what's going on. Yeah. Quip card cab this. Oh boy, what's going on here? All right. So first off, what is cab this? Kind of an odd expression here. Cab actually gives you the type of an example. So if I were to say cab 5, this would be a pat UD. Yeah, so in context, you know, I could even treat it as like a mold, right? Like I could actually get it back like it's a pat UD. So cab is short for buck cab, which is type of example. So I can give it an example of a thing. So whatever this is, whatever my current core is, which is dot here, it's an alias that I've defined up here. It's the shape of the thing, right? Return me a, you know, onInit will return me a quip card of this, of the kind of thing I have. Structurally, basically, there's some subtleties, but you can think of it as this. All right. A list of cards means all of the things that this agent would like to tell the world to do. Maybe it would like to send some data to air, or send some data over AIMS, or register some timers in Bane, or do other kinds of things with Arvo. Maybe it would need to communicate, like it would need to check and see, is some other agent running? I'm going to use PALS. Does PALS running? Let me send a card to subscribe to it and see if it actually is running. So what I'll actually be sending is a list of cards. In this case, I have no cards, so I'm sending a null. I'm sending sig. All right. Tisdot is used to edit an arm in the subject. So right now I'm changing the state in my current core, and I'm defining it to be this value, send 0 tar list path. So the bunt of the state. It turns out that in context, this is actually a repeat of this because that is the bunt, right? Like it's the same thing, but it's good to be explicit and just say, yes, I'm clearly setting up all these values. If I define a state 1 later on, I'll actually have to write a rule here that says if the head of my current state is 0, then how do I change it to state 1? We will do that in a later lesson, but you do not need to worry about it right now. And it will print a message that Bravo has successfully started up. All right, a lot going on there. A lot of things just happened there. Let's go ahead. This is going to need a lot of junk. It's going to need default agent, which has a whole lot of other requirements. So I'm going to build my desk differently this time. I'm going to merge it from base. So there's two ways to build a new desk. There's bar new desk, which is kind of a minimalist implementation. And then there's bar merge, which copies an existing desk, which means it may copy a lot of things that you don't need, but it will get you started here. So I'm going to create a new desk called Bravo as a copy of base, and I'm going to bar mount Bravo. Let me share those with you. Bar mount Bravo. Time-wise, I'm aiming for App School to probably be a little bit like an hour 15. It'll be a little bit longer than Hoon School was, but it'll be recorded if you have to drop off at the hour. All right, so we've created Bravo, we've mounted it. So now I should be able to see Bravo over here, and I can save this file that I shared with you earlier as bravo.hoon in Zod Bravo app. The other thing I need to do immediately before I do anything else is I need to, in Bravo, there should be a desk.bill. This should only contain Bravo. So also change desk.bill to this or sig cell send Bravo ser. Same thing, right? It's a list of agent names. So this is what we have here is a list of agent names. And in this case, one of them. All right, I should be able to bar commit Bravo. And okay, so it registers those 2 changes, only the 2, even though there's a lot more files because nothing else changed. And bar install our Bravo to turn the agent on. And if I've done it correctly, it should just work. All right, so I got my message. Bravo initialized successfully, and now it runs. All right, we went through everything. We looked at all this stuff that it's doing. So now let's try poking it. Okay, so earlier we did col alpha, ham noun, and then some data. All right, so I'm going to do the same thing here, col Bravo, ham noun sig. And this time, instead of just crashing, which is what it was doing before, I also get a message which says unexpected poke to Bravo with mark noun. This is default agent handling this and saying, you know, there's more information that can be provided contextually. So it's kind of nice to have that. So if I actually go to lib default agent and go look at on peak, you can see that this is what it looks like, unexpected pry into dap.bol. So dap was the agent on path. Well, sorry, that's a peek. I actually wanted a poke, which is with mark p.cage. So like, what is the head of the cage that was passed in. So default agent is nice because it just, if you do something that you didn't want or you didn't want to implement yet, it gives you a way of at least tracking what's happening. Are things going to the right place? The other thing that's really nice is I can do col bravo ace less debug. And this will spit out for me what my current state looks like. Right now, there are no values in Bravo. Right? There's no data in Bravo. There's nothing else for it to do. And so, like it exists, right? Like there are values. There's a list of values, but nothing I've done here changes those values. Okay, so that's what we're going to look at in 2 lessons is how do we edit this. Before I pivot away from this, the last thing I wanted to point out was lustar, which defines aliases in Adore. We're going to name this. We're going to give dot the name this so that we don't have to type dot if we want to talk about this. This is somewhat controversial, but the idea everyone has is that writing this out explicitly seems to be friendlier than writing sig dot inside of a cell like this, which does feel like a little bit spare, like a little bit sparse. That's kind of hard to read. So we call it this the same way that if you were using C++ or something, this would refer to the object that you're currently in. This is a reference to the core that you are currently in. And then this is a little bit complicated. This is an arm pull of default agent. This is an arm pull of default agent with the current bowl so that I actually have access to all the information from the current bowl, which is, of course, how I was printing this out a moment ago. All right, so that gives us debug information, even though we can't change anything. We'll start putting all these pieces together here. All right. Next time, what we're going to do is we're going to look at Arvo. We're going to look at basically what are the kinds of things that the operating system does for us on Urbit. Because this logic, these capabilities sort of define what Urbit knows about the universe, right? So if Urbit knows about a network, it knows about a network because of AIMS or because AIR, which is your AIR is your HTTP server, which means you're talking to other things on the internet. That's how it knows about what's going on in the world. If you are going to know about Azimuth, if you're going to know about Urbit ID, identity, the secrets that you can get, the public key infrastructure, you're going to know about through Arvo, through a vein called jail. So we're going to talk about that up first here in our next lesson. And then we are going to start working on how do we build agents that modify state? How do we build agents that interact with other agents? How do we hook agents up to different kinds of front ends, right? Like writing raw pokes this way, col bravo, pam noun, sig. This is kind of ugly and clunky, but right now we don't have anything hooked up to it, right? This is sort of like we're soldering on a breadboard with chips rather than having buttons or something defined. So we're going to look into that. And the ultimate goal of App School is for you to be able to write and distribute simple production quality apps. That's where we're aiming over the course of this and the next 7 lessons. What questions do you have about what we've seen with these agents so far, with what Gall does, with Alpha, with Bravo, with any of this boilerplate that we took a look at here? What would you like to know as we close out today's lesson? All right, some basic questions. Number 1, is there a way of defining a custom on something ARM? In current Gall, current Gall uses a model that's called static Gall. There is not. And so what you would conventionally do is you would define another core after it, like this. And then you will be able to access, this is called a helper core. And this helper core will do other things for you in the world. And you'll be able to refer to this neighboring helper core in your main Gall agent. So right now, this is what we do. Let's see. 2. So a card is like a schema type shape of the interaction between an agent and the OS. Yes, we have not looked at any cards in particular yet. Right now, I've just been passing an empty list of cards, but yes, basically it's a structural map for what does it need to look like when I talk to the OS. So this on Arva will receive this. Well, no, excuse me. Well, on Arva will receive this, but it'll receive it back from the system. And so there are different kinds of cards that we can pass around that have different names. But right now it's just the basic, it's the unit of messaging, right? So if you're used to like a message-driven, object-oriented context, it's like a message. It's a message schema. Think of it that way. Let's see. Next question. Where can I read more about Quip Card Cab This? All right. Quip Card Cab This, like I say, is you can think of it as maybe I'll write it like this. This line 19 that I just defined here. Quip is a gate that accepts the type of card and the type of the core that you're in, the type of the Gall agent core, and then produces a type that basically matches a list of cards and your core. Okay. You're going to see Quip Card Cab This everywhere, but structurally, this is what you're saying is line 19. All right. Question, is the agent state a list? What does it include? Yes, it is a list. This is what we defined here. The list named values. Right now, that list is empty. We have done nothing to add anything to this list. So we've defined state, but we don't yet know how do we change state. That's where we're headed next, or, in the next lessons is we're going to say, how do we change state? And then another question is, I don't see the event loop. Is the logic that handles this located in the OS? Yes. So what Gall will do is it maintains this interface and it maintains the actual agent state. And then every time you interact with it, what it does is it builds an event and it passes that information to Arvo, which is your main event loop, and that it will dispatch everything. And actually, if we want to, we should not be scared to look deeper into the system than we are right now. So let's go to Arvo. Arvo defines a ton of things and is kind of a big, it's not that scary of a file, but there's a part of it that's called the life cycle. And ultimately, Arvo is basically directly running a knock formula on the things that it receives. And this is how Urbit's event loop works. You're probably not ready to really poke around in Arvo yet. I mean, feel free to, but you'll get there. If you actually want to get into the kernel stuff, this is the event loop right there. That's the event loop. That's how Urbit passes information around. Next question, when does the agent state reset? So what do you mean by reset in this case? You can unmute or you can type. I don't really understand what reset means in this. Okay, does it reset every time I restart the agent? It does not. Okay, so this is interesting because once you start a Gall agent, that agent is running, and so it can have an upgrade from one state to another, but the state itself does not actually clear unless you explicitly clear it. So that would be the bar nuke. So I could bar nuke Bravo, And this will clear the state and turn off the agent, and I would have to manually start the agent again to get things running. I don't have any state, so right now there's nothing for me to say or do with that, but that is how I would clear it. So on init, the shorthand is on init is run once the first time you install an agent. And from then on, every time that you modify the agent, it runs on save to save the current state, and then it runs on load to upgrade the state if it needs to the next thing. That's the pattern that it will do again and again. The difference between bar nuke and bar suspend is bar nuke turns the agent off and clears the state. Bar suspend just turns the agent off, which means you can't poke it and it will not receive subscription responses and so forth, but the state is still preserved. Let's see, there was a question I missed in the middle there, which is Gall reminds me a lot of component-based front-end components like Halogen and React. Knowing it basically amounts to this runs at this moment and that runs at that moment. Yeah. In a sense, I think that's a model you can think about this. Another question: can agents be coded in languages other than Hoon? So in principle, yes. Anything. Well, so there's kind of two parts to this question. One is anything that could run in that would compile to Nock could be run inside of Urbit because Urbit knows how to run Nock. The caveat on that is there really isn't much in terms of agents that are languages other than Hoon. Probably the most salient example is Sockripe wrote a program called Hick, which is a Lisp that it's kind of a Lispy Hoon that compiles to Hoon and to Nock. Other than that, people have not at this point really bothered to write things other than Hoon that compile to Nock, but you definitely could. The other part of the answer to your question is, could you have something other than a Gall agent run in Urbit? And that is to say, Gall is our user space framework, and it's the one that you're writing for, and it's the only one that exists on Urbit right now. But in principle, you could write a different user space handler that had a different philosophy of how programs run. We haven't talked about threads yet, but when we look at threads kind of represent an alternative way of thinking about running programs. And so I think we get to that in lesson 5. So watch for that when we get to lesson 5 and say, this is kind of a different paradigm for thinking about how do I run a program. So ultimately, we will get to that kind of point as we move forward through this. All right, I think that dries up our most of our questions right now. Yeah, Hoon is already extremely Lispy. Being homoiconic is enough. Yes, Hoon does feel very Lispy. Actually, there's a blog post I wrote back in June, comparing Lisp's philosophy to Hoon's design philosophy, and so there's some things you can take a look at there if you're interested in that. Can Gall apps be completely removed or just be suspended? In the sense that you probably mean here, there's not really direct support for completely removing a Gall app. This is one reason that we really prefer to do our development on fake ships rather than on live network ships. So you will see people use, there's basically 3 philosophies for how to build ships. One is to use a comet, one is to use a moon, one is to use a fake ship. Mere mortals do not develop on their live ships because you would probably end up breaking things in interesting ways if you did that, and you'd have to breach your ship. So right now, Gall apps can be nuked, they can be suspended. They cannot really be removed from a ship once installed. Not to say that couldn't happen at some time in the future, but that's currently not a use case that's part of the developer experience. All right, great questions. I see a lot of familiar PatPs, familiar names here, so I'm glad to have you all on board. Once this lesson is ready, processed, I will post it to YouTube, I will post the lesson notes, which are a little bit more extensive than what I'm able to cover live, and post the homework. You have until the end of the class to finish the homework. I encourage you not to leave it until the end of the class to do it. But we will go ahead and proceed that way. So I will see you all next week as well. Thank you.